So hello students, this is me again, and now we'll talk about the section 2 or the part 2 of sequence and series, where I'll teach you how to derive the formula of the nth term or the sum of any AP or any GP, right? So let's begin. So hi, this is Utkal. I'm in IT Daily right now, and I teach physics, chemistry, maths in Urban Pro, right? You can contact me anyway, right? Now let's start the topic. In the previous class, we talked about general forms of APs and GPs, right? So we'll go back to the general term. So what was the generalized form? Generalized form of an AP, if you guys remember. I want you to pause the screen and write it on your own, right? It was A, which was the first term. Second term was A plus D. Third term was A plus D plus D. You have to just add these to get the next term. A plus D, right? Dot, 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 dot. Now, it can be written as A plus D, A plus 2D, A plus 3D, right? This was the generalized term of an AP. Now, to find the nth term, so this is the first term, this is the second term, third term, right? Fourth term. Our mission is to find the last term or the nth term. Now, finding nth term is not a rocket science. You can easily compare any two formulas and you can get the nth formula, right? How to do it? See, just compare it, right? Just find a pattern. What is the pattern? Here, if let's assume this is the third term, we're looking at the third term. Third term is A plus 2D, right? What is the fourth term? The fourth term is A plus 3D. Here you can correlate that any term I go, this multiple, which is multiplied to the D, the common difference, is 1 less than the number of term, right? If I talk about second term, D is multiplied by 1. 1 is 1 less than 2. If I talk about the first term is nothing but A plus 0 times D. It is also 1 less than 1, that is 0, right? You can notice a pattern. If we talk about the fourth term, it is A plus 3D. What is 3? 3 is 1 less than 4. Now, if we talk about what will be the nth term, very easy. A is constant everywhere. A is present in every term, right? The formula. If we talk about the nth term, what will be the thing which will be multiplied to D? What will be this thing inside this? It will be n minus 1. Yes, you guessed it right. A plus n minus 1D. Just remember this, right? It is very easy. At any number of term I go, it will be A plus 1 less than the number of term multiplied by the D, right? So hence we can write the nth term of an AP is what? A plus n minus 1D, where A is the first term, n is the nth term or number of terms, and D is the common difference, right? Now let's talk about the sum of the terms of an AP, right? Summation of all the terms. If I ask you what is known as the sum of all the terms of a sequence, it is known as a series, right? As I taught in the previous class. Now, to find summation of all the terms of an AP, right? Now, again, the generalized form helps us the most. What was the generalized form? A plus D, A plus 2D, A plus 3D, dot, 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 dot. Now we got the nth term. What was the nth term, if you guys remember? A plus n minus 1D, right? Yeah. Now, our motivation is, or our aim is to add all of those. A plus D. plus a plus 2d plus a plus 3d dot a plus n minus 1d, right? Of an AP having n terms. Let me specify that. Okay. Now let's sum all of those, right? Summation is very easy, right? How many a's are there in the equation? Can anyone tell me? If this is a first term, this is a second term, this is a third term, fourth term, this is the nth term. How many a are there in this summation? There are n a's, right? Because for each term, there is a term of a. So there are n a's. So what we can write is summation would be na plus. Now comes the trickier part. Not harder part, but a trickier part. Na plus all the remaining d's, right? 1d, 2d, 3d, n minus 1d. D plus 2d, sorry, plus 3d plus n minus 1d, right? Now we have to add all of these. Let's take d common. Na plus d common out. It's nothing but 1 plus 2 plus 3 plus n minus 1. Now what is this? This is nothing but just summation of n minus 1 natural numbers. It's nothing but summation of n minus 1 natural numbers. Now, if I ask you a simple formula which you have maybe learned in class 8th or 9th, what is the formula of summation of n natural numbers? Summation of n natural numbers. It is nothing but n into n plus 1 by 2. All of you know this formula, all of you are aware of this formula. Let's check. Let's sum 1 plus 2 plus 3 plus 4 plus 5, right? How many terms are there? There are 5 terms, right? Let's put n equals to 5. It's nothing but 5 into 5 plus 1 by 2. That is 5 into 6 by 2. That is 15. Let's add all of this and see if it gives us 15 or not, right? 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 2 is 14. 14 plus 1 is 15, right? So we got LCM, LH is equals to RHS, right? So the sum of n natural numbers is n into n plus 1 by 2. Here, the tricky part is there are not n numbers, but n minus 1 numbers, right? So we'll substitute n minus 1 in place of n here. So what will we get? Equals to na plus d. Now just substitute n minus 1 instead of n here. There's n minus 1 multiplied by n minus 1 plus 1 by 2, right? What is this? It's nothing but na plus d n minus 1 multiplied by n by 2. Let's take n common. If we take n common, it's nothing but a plus d into n minus 1 by 2, right? What is this? N by 2, 2a plus n minus 1d, right? I took 2 out. I multiplied 2a. It can be written as 2a by dn minus 1, and I took 2 out and as n by 2, right? So we got, voila, we got the formula of the summation of sequence, which is in an arithmetic progression and as n terms, right? So we got the formula of it. Let me summarize it. Summation of n terms of an AP having A as the first term and D as the common difference, right? Hope all of you got it. Now we'll talk about GP, right? What is GP? GP was geometric progression. We'll talk the same about GP. That is the nth term. We'll formalize the nth term and we'll also formalize the summation. Right? Let's talk about GP now. This is AP. Now, coming back to the general form, right? What was the general form of a GP? It was AR, AR square, AR cube, right? Dot 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 nth term, right? Now, how to find the formula of the nth term? Again, just find the pattern, nothing else. It's very easy, not rocket science, right? Fourth term. You can notice again that every term, the power of R is 1 less than the number of terms. If it is a third term, the power of R is 3 minus 1, 2. If it is fourth term, the power of R is 4 minus 1, 3. If it is a first term, the power of R is A into R to the power 0. That is 1 minus 1 is 0. So we can say that the nth term would be nothing but A is constant everywhere. In each term A is there, so A would be present. And R to the power 1 less than the number of terms, that is n minus 1. Right. So hence the nth term of a GP is A R to the power n minus 1. Right. Let's talk about the summation. Summation of terms in GP. Right. Now, again, let's come back to the general form. Is AR, AR square, dot dot dot. We know the last term now, AR to the power n minus 1. Let's sum all of it. A plus AR plus AR square plus dot 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 plus AR to the power n minus 1. Let's take A common. If we take A common, it is 1 plus R square plus dot 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 R to the power n minus 1. Now, do you know the formula of 1 plus A square dot dot A to the power n, right? There's a formula again which you learned in early classes. The formula for this is A to the power n, right? A to the power n plus 1 minus 1 over A minus 1, right? Now, let's check the formula. If I talk about 1 plus 2 square plus 2 cube plus 2 to the power 4. Here, what is n? If we compare with this, n is 4, right? Now, let's put n equals to 4 in this equation. What will we get? And here, A is the first term. What is A here? Right? A is not the first term. A is the second term here. So second term here is 2, right? So we put 2 n plus 1, that is 4 plus 1 minus 1 over 2 minus 1. This gives us 2 to the power 5 minus 1 by 1. That is 31. Let's check if this gives us 31 or not. 2 to the power 4 is 16. 2 to the power 3 is 8. 2 to the power 2 is 4 plus 2 plus 1. Let's check. It is 16 plus 8 is 24. 24 plus 4 is 28. 28 plus 2 is 30. 30 plus 1 is 31. Hence, they match, right? So this is the formula for n terms. But again, right here, there are n minus 1 terms. You got my point? N minus 1 terms. So for this, it will be A into R to the power n minus 1 plus 1 over R minus 1. R is the ratio, common ratio. Now, what is the summation formula we got is A into R to the power n plus 1 over, sorry, minus. Right here, it was minus. N minus 1 over R minus 1. Again, we got the formula of the sum of first n terms having n terms. Now, this was for finite GP, which ends here. What about an infinite GP? If I talk about an infinite GP and the common ratio R is greater than 1, then the GP will be increasing in order, right? Because we're multiplying something greater than 1 to each term above. So if you go to infinity and see, if you go at the last point, it will be like so big of a number because it is multiplied by a very big number. So in this case, if we talk about the sum will be nothing but infinite, right? Because if we start from here, it will increase exponentially, right? And the sum would be infinite, never ending. But first case. Second case, if R, mod of R is in between 0 and 1, R can be negative, positive, both. But if it is in between 0 and 1, that is you're multiplying the previous number with something, 0 point something or, less than 1. Then it will decrease in order like this. Obviously, the sum won't be exactly same, but somewhere you can converge and the sum won't be infinity, right? So here, the formula of sum is sum for infinite GP A upon 1 minus R if R is less than 1 and greater than 0, right? Let's take an example of first case. 1, 2. Here the common ratio is 2, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. The series is never ending and increasing and increasing and increasing. Hence, the summation would be infinite. But here, if I talk about an example, if I start with 1000, right? And I take A equals to 1000 and I take R as half or 0.5, which lies exactly in between these, right? So what will be our sequence? Sequence would be starting from 1000, it will go 1000 by 2 is 500. 500 into 1 by 2 is 250. 250 to 125, right? 62.5, right? So it is decreasing in order, right? And at specific place will converge. So here we can just straightly put in the formula. S infinity here would be 1000 over 1 minus R. Here R is zero point 0.5. 1000 by 1 minus 0.5, it is 1000 by zero point 0.5. Nothing but 2000, right? So here I'll conclude my second topic. Thank you so much for listening, right? This was a topic where I discussed nth term and the sum of terms of AP and GP. You can contact me via my profile in Urban Pro for other topics as well, for questions or for properties of sequence and series. Thank you.